Okay, everybody, here is the review for tomorrow's test. So let's go through this. On question number 1 and 2, we need to remember that if we have a fractional exponent, the top number is the power, and the bottom number of the fraction is the root. So in number 1, that's the 4th root of x to the 5th. Okay, that's a great answer. I took a little further. You don't have to take a little further. Okay. Number 2. What I need to do is add exponents. So if I want to add exponents, and by the way, I'm going through this, you can pause this video anytime you want. So if I have to add exponents, I took my 5/4 plus my 2/3. I just lined them up. I'm just adding a fraction. So a common denominator between these two fractions is 12. So 3 goes into 12 4 times, times 2 is 8. That's an 8. And 4 goes into 12 3 times, times 5 is 15. So then I just added the two fractions. 15 plus 8 is 23. So one answer could be simply x to the 23 twelfths, which is the 12th root of x to the 23. And then, of course, I took it a little bit further. You don't have to, okay? Number 3, we're going to do just the opposite. If that's the power, that's the root, there we go. Then I've got to the 4/5 power, okay? 4/5 power, that's it. 4, I'm just going to add my exponents. I got 1/2 plus 3/2 plus 1/2 makes 2.5. So that's x squared. And, of course, 1/2 power means square root, okay? 5. Well, if you have a negative exponent, that means 1 over. So if I have 1 x to the 5/4, okay, because of the power and the root, and then I just brought it up with a negative exponent. So I like to bring it up as a negative exponent. I want to show negative exponents as fractions, okay? We've talked about that before. 6, okay, now 6, we want to base 2. So that is a 2. I just left it alone. 16 is 2 to the 4th, because 2 times 2 times 2. Okay, that's 2 to the 4th power. And then 8 is just 2 to the 3rd power. Now what I did then is I brought the 2 to the 4th power up. So I rewrote this as 2 to the x plus 1 times my 2 to the negative 4 times my 2 to the 3rd. Okay, I brought that up as from an exponent. And then I'm going to add exponents. So I add up my exponents. I've got x plus 1, negative 4, 3. That makes a negative 1 plus 1 is no x's. So it's just 2 to the x only. Okay. Number 7. Okay, no, 32 is the same thing as a 16 times 2. Square root of 16 is square root of 2. Square root of 16 is a 4. And then the square root of 4 times 3. 4 times 3 is 12, so we get 12 square root of 2. 8, I'm going to multiply the whole numbers. 2 times 5 is 10. I'm going to multiply the square root numbers. Square root of 5 times square root of 5. 5 is square root of 25. The square root of 25 is just a plain old 5. 10 times 5 is 50. Okay, number 9. The 3x is out. I'll leave it out. 48 can be the square root of 16 times the square root of 3. And, of course, then I took half. I'm going to take half my exponent, okay? So that's just x to the 7th. Square root of 16 is 4. So that comes out. So what's out? What is out? Well, 3 times 4 is 12. I got an x to the 7th with an x makes x to the 8th. The square root of 3 has to stay in because I don't want any other answer than that. Okay? Because, you know, it's an ugly number, ugly decimal. 10, I just wrote it twice. Quantity squared. So I went 2 square roots of 5 times another 2 square roots of 5. And then I multiply. 2 times 2 is 4. Square root of 5, square root of 5, square root of 25. I know the square root of 25 is 5. 4 times 5 is 20. Okay. 11. Okay. I know that the square root of 125 is 25 times 5. I need to take half of this. So what I did is I broke it up into x to the 6th and x to the 1. I did that so I can take half of that exponent right there. So here's what I did. So I've got it broken up. I took the square root of 25. That's 5. Boom. I took half of this exponent, which is x3. And the rest, this 5 I cannot do, and this x I cannot do, so they both stay inside the square root, okay? 12. In 12, I left the 2x to the 5th out. 20, I rewrote as the square root of 4, square root of 5, because I want the square root of 4. 9, I'm going to take, and I need to make it even so that I can take half of it. So I made it a x to the 8th and an x to the 1. Everything's broken up. Let's take some square roots. Square root of 4 is 2. Okay. Half, take half of that, half of my exponent, makes an x to the 4th. And let's see what's left. Okay, so then on the outside, 2 times 2 is 4. X to the 5th, x to the 4th is x to the 9th. And what's left inside still is 5. It's still this x, so they both stay inside as square root of 5x. 13, I got to multiply. It's just a big, ugly problem, but I'm going to multiply outside. So 4 times 5 is 20. X squared, and x makes x to the 3rd. Now inside, I still have to multiply. 3 times 18 is 54. I've got an x to the 3rd. X to the 7th makes x to the 10th. Okay, so 20x to the cubed is out. What's inside? Well, we can break up 54 into 9 times 6. I like 9 because I can take the square root of 9. I can take half of that exponent, make it x to the 5th. Okay, so let's see what's left. On the outside, I got a 3 here. And this 3 times this 20 makes 60. On the outside of an x to the 3rd, x to the 5th makes x to the 8th. But what's left? Just this square root of 6. I cannot take the square root of 6 because, again, just to show you again on these darn square roots, if you take the square root of 6, it's really an ugly decimal. I don't want that. I'd really rather not write that decimal, so I leave it as the square root of 6. Much nicer answer, okay? All right, let's look at the back side. Again, if I'm going too fast, just pause it and look, okay? Now, you guys are having a difficult time with this. Let's see if I can do a better job of teaching, okay? This is one term, 5 square roots of 3, times another 3 square roots of 3. And then I'm going to multiply it times the 4. So it's 2 multiplications. So first of all, multiply whole number with whole number, 15. Square root number, 3 times 3 is 9. And then I'm going to distribute, I'm going to also multiply to the second term, to the 4. Whole number to whole number, 5 times 4 is 20. I got a negative 20. And then I bring along, because it's one term, square root of 3. All right, now let's see what I can do. Well, I know the square root of 9 is 3, regular old 3. And then I can multiply my 15 times my 3 is 45. And my 20 square root of 3, I'm just going to have to leave again. Same kind of thing. The square root of 3 is this really bad number. And I don't want that number, so I'm just going to leave it as the square root of 3. You cannot add these two terms because they are different. So that's my answer. Okay, number 15 is a FOIL problem. So this is one term. I'm going to multiply it times this term. Okay, so 5 times 4 is 20. Square root of 2 times square root of 2 is square root of 4. Then I'm going to multiply it times the negative 3. So the whole term. So I get a negative 15, whole number with whole number, square root of 2, because that comes along with that term. Okay, and then I multiply these two. Okay, the inside. I go 2 times this whole term. 2 times 4 is 8. And I have to remember the square root of 2 is part of that problem. Okay, so I get 8 square root of 2. And then finally the last, I just go 2 times the negative 3 is negative 6. Now let's see what we have. Let's see what we have. So I know if I go back to all of this, square root of 4 is 2. All right, it's a regular 2. 2 times 20 is 40. These two square roots can be combined to make a negative 7 square roots of 2. Bring down the square root of 6. Finally, whole numbers, 40 minus 6 is 34 with the negative 7 square root of 2, and you cannot add those. Those are different, okay? All right, how do you graph a square root? Well, we know you can look at it in Desmos if you want to, but it looks like this because we know the numbers, we can't plug in any numbers. We can plug in, we can let x equal 1, x equals, well, I'm going to let x equal 4 because all the other numbers, like if I let x equal 3, we know the square root of 3 is that ugly decimal, okay? Hey, Carl, I'm in the middle of recording, but go ahead. Come on. You want me to come on down?
Whatever.
Okay, they're listening to us, which is great. They're going to say, who is that, Mr. Hab? All right.
Hi, guys.
Give me. Yep, exactly. Get to work. So then I'm also going to plug in x equals. That was Mr. Hab. He's an awesome guy. The reason I picked these numbers is because I can take the square root of 1. So I start at 0, 0, right? Because x can be 0. So I start at 0. The square root of 0 is 0. The square root of 1 is 1. So 1, 1. Square root of 4. I plug in 4 because that's the next good square root. So I plug in 4. Square root of 4 is 2. I can plug in 9 because that's the next good square root. Square root of 9 is, so I go over 9, 3. And then I'm going to move this. Okay, we've done this before. We've done translations. So then I'm going to move it. Okay. So I know that I'm going to take my square root graph and I'm going to move it to the right. Remember, it's the opposite. I'm going to go to the right, 2, and then up 1, right? So I did that. I just took my whole graph, moved to the right, 2, and up 1. There's my new graph. Okay, now, that's not so bad, but what about domain? Well, domain, remember, there's no graph back here. You start at 2, and you go forward. What about range? Start at height of 1 and go up, okay? And that's that. Okay, hopefully we can talk about that today in class. All right, on to 17. Okay, Sally needs to invest $30,000. There are 2 banks to invest in. Simple interest. Simple interest is amount is equal to my principal plus my principal times my interest rate times my time. Or cash bank, which is compounded, and that is going to be my principal times 1 plus my rate to the t power, okay? So she takes her 30,000 simple interest plus another 30,000 times my 0.03 times t. That's times t. It just got a whole punched off. The other bank, cash bank, is going to be 30,000 times 1 plus my point, that's a point in there, 0.025 to the t, okay, because I take my 2.5%, move the decimal 2 places, 0.025, okay? Great, there's my 2 functions, and then what I want to do then is just figure out what they are for 30 years. I plug t, I put 30 there, I use my calculator, I get 57,000, okay? For my cash bank, I put t, I put my 30 up there in the exponent. I can show that if you need to. I could just go 30,000 in my calculator, 30,000 times 1 plus my 0.025 to the 30th power, and there I get about $62,927, okay? All right. And then if I graph them, they both start about 30,000, right? And then after 30 years, I can graph those numbers. Cash bank is eventually more on the long run. It's less in the short run. It curves slightly. Money bank, straight line because it's linear, okay? All right, that's all I have. If you have any questions, come see me. We're going to do this in class, so make sure you know what you're doing.